So basically, this project is just a simple Java project. It has one package count.example.demo and a class with the main method in it, right? That only prints sys out. So my question to him was, what if you have an API that gives you a particular set of items, a limited set of items, and to get more items, you will have to request to that API again. So basically, you might call it as pagination, right? You implement pagination in your applications. When front end would request for some data, you give them limited information, and after that, if they want more, they'll request you. You'll give it more, right? So what if this is not the front end? This is a back end service requesting to us some third party service for data. And what if you want to limit this data with respect to your consumption, right? For example, there is huge data that the data set that you have configured with, and when requesting for the data set, you get only a limited amount of data, and then you consume it, and then once you require more, you ask for more. So that's what we are going to achieve today using streams, right? Java streams, and I want to explain like how on demand data consumption happens in stream. Okay, so what I did was yesterday I created a method, right? I created a private static method that would give us a stream of integer, right? Call it as get integer string. Okay, and it will not accept anything. It will just give us a integer string, and it will return. For example, for now, let's return an empty string, right? So how we are going to consume it is basically we will call the stream, and for example, we only want to limit it to 100 records, right? 100 records. And for each element, what we are going to do is we're going to print it out, right? So this is how we are going to consume. From the stream, we expect n number of elements. We are going to limit it to 100 elements, and for each element, we are going to print it out, right? Everything is clear until now, right? So to mimic pagination, what I'm going to do is I'm going to create a static random here, right? Private static final random is equal to new random, right? And I'm also going to create a method private static list of integer. This method will return a list of integer, get limited, get a random, for example, random integers. Integers, okay. So the limit to get random integer is, let's say, 10. Okay. So what I'm going to do is I'm going to create an int stream for a range of 0 to 10. So this will create 0 to 10. Okay. This will loop for from 0 to 9. So the the first index is inclusive, the last index is exclusive. So what we'll get is map to object, and we'll have the index here first, and what we'll do is random dot next int, not this one dot next int, and we'll just add this index just for fun, and we'll mark it to to list. Okay, so basically instead of doing anything else, we'll just return. So what this random integers is doing is every time we call this method, it will return 10 integers randomly, right? We'll just what we'll do is we'll just sys out the date time java util date. whenever we are calling this. Okay. Now, the challenge is that you are not going to pass anything here. There is no parameters, as you see, right? This method is calling get integer stream, which the stream is going to the integer stream of integer is going to be returned, and this is where you actually generate data. You don't need to pass anything. You just call this method, and you'll get 10 elements. So the challenge that I gave the candidate was, how are you going to write the implementation in here? So like if anyone has any suggestions, anyone thinks that there is a solution, just you can just pitch in and let me know. Okay. So this is very important, because the way stream works is, stream doesn't even care, Java stream doesn't care about the source or how big the source is, right? It consumes one element by one. This is very important. No matter how many intermediate operation you put in, it doesn't care. It all depends on the terminal operation, on how the stream is going to consume the stream, right? I'll give you the example of that at the end of this demonstration. Let's see, let's see how other collections create stream. For example, if you have a list, right? If you have a list of, say, integers, and I'm just creating a list here with no elements in it, and you can just call stream to it, right? You can use any collection, or if you have an array, you can do arrays.stream. So when you call the stream, what happens basically? So if you go, you can see that it returns a stream using the Spliterator, right? The Spliterator and the stream support class that it passes the Spliterator to, and this is something false, which is parallel. Do we want a parallel execution or not? That's what this is doing. Let's do. Let's use the same expression that they have used. Let's use that in our case as well. Okay. So let's see. Now we have stream support, which will help us create a stream using a Spliterator. Okay. And the parallel is something that we'll discuss later. Okay. We'll just keep it as false for now, because we don't want any parallelism. Now I asked him to figure out, okay, now figure out what Splitterators are. And what you can do is, you can either look into the execution of Splitterators, that how Splitterator is created, or you can Google about how Splitterators are, and then you can do. So Spliterator, the main difference between Spliterator and iterator is, iterator is basically something that iterates over the elements of a collection, right? May it be an array. If you create an iterator out of an array, then you can iterate over the elements one by one. In Spliterator, we have this capability to split. Okay. So for example, if you have 1,000 elements in a collection, and you can, using Spliterator, you can call try split method, which will give you an Spliterator again. So now you have two Spliterator. One Spliterator will iterate from 1 to 500, and the other Spliterator will iterate from 501 to 1000. This is how they are doing multi-threading. Like, this is how they are using multiple threads to process streams. This is why streams are fast, right? You can create a Spliterator out of an iterator. Okay. There is a method in Splitterators now. And if you take collection, you have collections, right? Collections is a util class that has some convenience method that you can use. If you have collector, you have collectors that is a util class that you can use, that has some utility methods for convenience. So for uh, Splitterator, there is a Splitterators class, right? Splitterators that you can use for convenience. And in that, you have Splitterators of unknown size, because we don't know what the size of the iterator is going to be, right? When there is a collection, like the collection dot size, you do collection dot size, you know what the size of the collection is. But in case of iterator, you might not know. So let's do splitterators of unknown size, and then you have to figure out what the iterator is. So I'll pass null, and then what I'm going to do is there is something called how you want to split it, how you want to iterate it, or how you want to function it is called the characteristic. So there is something called ordered, which will do it orderly. So that's mostly what we use, but there are other options as well that you can basically go here and you can see, like in the Java doc, the whole explanation is there on how it is going to iterate or how it's going to function. Okay, so let's create an iterator. Okay, iterator of what? Of list of integer. Why list of integer and why not integer? Because what I'm going to do right now is whenever I want some data, I'm going to request this method, and this method is going to return list of integer. So that's why every time I iterate, I'm going to get a list of integer. That's why I'm creating an iterator of list of integers. Okay, for now I'll just call it iterator is equal to new iterator. Right. This is basically we are giving an anonymous implementation right away for an iterator, and we don't need this. Okay. Whenever you create your own iterator, there are two methods that you need to mandatorily override. One is has next, and one is next. Okay. So next, we know that whenever we are going to request for a set of data, what we are going to do is we are going to call this random integers. So for this, it is very easy. I just replace this. Okay. And in most cases, this will not be how you are going to implement it, because in most cases the data isn't unlimited. There is always a limit over the data. So if there is more elements or not is decided by this method has next. If has next is going to return true, it will call the next method, or else you are not going to call next, right? Whenever you might have used iterator by yourself, you always do while has next, while iterator dot has next, then you call next method, and then you get the actual implementation. So this is very important. In our case, I am dealing with unlimited set of data. There is no restrictions. Whenever I am going to call it, I'm going to just call this random integers method, and it is going to return n number of data for me. So no restrictions. So I'm just returning true. But in production, in actual use cases, this is never the case. You always need to check a condition if the data is depleted. If it's depleted, you based on that condition, you will return false, and whosoever is consuming this iterator will know that there is no data and they will stop consuming. Right? Now that I have an iterator, I can pass it in here. Right? So using this, I now have a spliterator. I'll just call it spliterator for now. And then I pass in the spliterator to the stream support. Now what is happening is return stream.empty. What is happening here is, as we created an iterator of a list of integers, what it is giving us at the end is not stream of integers. It is giving us stream of list of integers. Right. Whenever you want to, whenever there is a stream of an object and you want something that is within an object in the stream, you use something called flat map, right? So when you do list of streams, what you have to do is you'll have to flat map, because using flat map, I can access the elements within the stream and then return the stream of those elements. So instead of my stream being the stream of parent elements, my stream now converts to stream of child elements. So now here we are getting a list, So what I'm going to do is the list is itself a collection. I can just call a list of stream, right? Or better, we can just do you can just use method reference to do collection colon colon stream, right? Like this. This is going to return a stream of integer. Just formatting it. Now, how stream works is the base of this demonstration. As I said, the stream never knows all of its element. Based on the terminal operations, it decides how much element it wants to consume, right? For example, if I say I want 100 elements here, right? This method should be called 10 times because each time it is going to return only 10 elements for me, right? If I say I want 1000 elements here, this method should be called 100 times, right? But what if I only want 99 elements? When I only want 99 elements, this method will still be called 10 times. And in 10 times, after calling it 10 times, it will have 100 elements here. And after having 100 elements, it will eliminate one and only pass 99. Okay. But for now, I'll say I want 100 elements. The second thing to keep in mind is it won't generate elements. It won't start consuming from the very beginning until and unless there is a need for it, right? So when I say 100, it doesn't mean that it calls this method right away. That's why we have the print statement here, so that we know when it is being called, right? So let me run this. Let me run this method. In the console, you see that it requested it requested for 10 elements. Then it consumed it one by one. All the 10 elements were consumed one by one. And after that, it called once again. So until and unless it consumes, it wouldn't even bother collecting the data, right? Why this is important? Because most of the time, what we do is we do some intermediate operation. We do some side effect in stream, which is very bad. We should never do any side effect. For example, while doing in stream, we are updating something else based on that data. It is never a right decision, right? What if I just do find first, if present, and then sysout, right? What I'm doing is I am limiting 100 elements, and I want the first element, and then I'm printing it out. Okay, let's run it and see for ourselves. Only once. So this is why it is very important. This is why we should never have side effect, right? We should never have a side effect in the stream. A stream should only be uh, for the purpose what it is there, because the terminal operation basically decides what is going to happen and how much elements we are going to accept, right? Now coming to the part where we had false here, right? We had set parallel false. This is where we say no, only generate enough elements that we want to consume. Don't keep on generating. What happens if you say, like, if I keep it to 100 elements like it was before, and I'm consuming only 100 elements, but I say, okay, don't do it in orderly fashion, do it parallelly, make the fetching parallel. Now what happens, you can see. This is how many times it fetched data, which is not even required. In some cases, yeah, parallel fetching might be required, But in most cases, no. Most cases, we should always keep it as false because we want to only fetch uh, for the elements that we want to consume. We don't want to fetch more. That's it with this demonstration. Any questions?
Keshav, when you set the parallel to true, so
Mhm.
that is like it acts like a parallel stream now.
Yes.
Okay.
So as we have not split the splitterator, one splitterator is consuming and one is parallelly generating data. And now this CPU has 8 cores. So one core is only consuming, 7 cores is generating data.
Okay.
So like the final, where is it? So the final consumption has only happened after being generated data so many times.
Okay. And one more thing, like you said that there should not be any side effects. So you mean that the methods like filter and map that we should not use.
No, 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 no. That is intermediate operation. By by that, what I mean is, what if I have an atomic integer, right? I say I want an atomic integer saying count total fetched, right? Total fetch, and I set it to 0. So just for an example, what I'm doing here is this total fetched is basically, or the size total data. Let's call it total data, right? This is going to represent the total data that there is there in the remote data source that you have. Now what I'm going to do is for I'm going to map here, okay? Or let's say I'm going to peek because I don't have to do anything. While peeking, I get some integer, and whenever I get some integer, what I'm going to do is I'm going to increment the total. So the idea is here is like when we call the integer stream, we are basically getting all the data that we want, and for each one, if while processing each one, what we are doing is we are incrementing the data, and at the end we are saying, okay, the total data is this, right? For example, if I this out, if I say total data, it's atomic integer, which is sorry plus total data dot get, right? Now, I have seen these use cases where this is called a side effect that is not related to stream, but using this stream, we are trying to do something else. Now, if I in this case, the total data you can see. Let me make it false, right? The total data is how much? 100. We have only limited to 100 elements, but as I said, uh, find first and then do if present, right? Run again, it will only give 1. So side effects are not at all reliable. This is a side effect that we are doing, right?
Yeah.
No.
Okay.
Okay.
Yes. Yes.
Any other questions?
Like I did not get like what is the firstly also like there was 100 data and using this also it was 100 data. So what is the difference? Like I did not get the point.
Using this, it is not 100 data. Like with find first, if I run it, it is only 1. The
Yeah.
total
Yeah.
data is only 1, right? So if the use case was to understand what was the total data that was on remote using this stream, it is not at all reliable,
Okay.
right? Because how stream is being consumed depends on the terminal operation.
Yeah.
That's why we cannot have any side effects.
Okay.
Yeah. Map and flat map are intermediate operations, so that's okay.
Map
Just
and filter, right?
yeah, map, filter, and everything. So whenever you are interacting with the elements in the stream, that's okay. But using these elements in the stream, you are trying to modify something that is outside the stream, is what is called side effect.
Okay.
Cool. Then that's it. That's it from my end. Thank you.